Hi, Leonidas. I'm going to answer your questions with a video. Hopefully, it makes it easier to understand. I believe Samson already addressed the questions, but I'll do it just in a visual way. Regarding question number 1, I did not neglect the fact that the axis of rotation is by your knee. And, I'm going to design here the axis of rotation on the knee. But if you observe here, they will not influence the calculations because they actually lie on the same axis here. So when I calculate those moment arms, they're going to be the same for the resistance moment arm and the same for that effort moment arm. So it does not matter in this case. As long as I keep those heels and knees aligned as I row, everything is good. But you're correct. I'm going to make that change and at least mention that. Now, what is actually changing is, if we go back here, so I'll fix these axes of rotation and I will put up over here. The center of mass is actually going to change slightly. And that's going to explain why we have the difference in values here. And notice here that probably the center of mass is going to shift a little bit to this side. It's a tiny bit, making this moment arm here, this blue one, making this blue one probably be a little bit bigger. And by being a little bit bigger, it means that if this one is a little bit bigger, this is going to be a little bit bigger. And that's why my theoretical value here is a little bit lower than the actual one that I measured. But it's kind of relatively the same. All right, so going to your second question. Again, Samson already addressed this, but I'm going just to put it in a visual way. We have the axis of rotation by the heels in the center of mass, and I'm going to design in blue the lever arm, the resistance lever arm, so the distance between the heel and the center of mass. And in red, I'm going to put the effort one. So in this case, our effort is around here. This is the force. So I'm going to measure from here to here. But we know that torques is a relationship between moment arms and forces, but they need to be perpendicular. So in reality, what we care is about this moment arm for the effort and this moment arm for the resistance. And now the interesting part here is that we actually know the relationship between the moment arm and the lever arm, which is given by this cosine. I'm going to put with the bright color, and it's the angle, the difference between this. And notice that they actually change at the same rate. It's affected at the same rate. The angle is the same for the resistance and effort, and that's why when I substitute these on the equation, these cosines here cancel out, and the ratio is just the same as when we are on the bottom position. So now what is actually going to happen here is that the force, while the force here, I'm going to put in red, while the force on the bottom position here is applied by the shoulders and the lever arm is this distance over here, on our second case here, I no longer have a force over here. Notice that my force shifted a little bit to this side, and that's what's going to affect actually these lever arms. So this lever arm over here is going to be less, which makes this one to be less, and the force going to be higher. And that's why you have the force on the top position is actually a little bit harder than the bottom position. Now, going back to the other position that we have here, it's very interesting here to analyze. We can do the same thing here. So I have a force applied over here, and this is going to be the effort moment arm, the lever arm, sorry, which is equal to the moment arm because they are perpendicular to that force. In our second case, actually, this force is going to be applied slightly different. So if I go and I design these, remember, moment arms needs to be perpendicular, and my lever arm is also a little bit shortened. And here you go, I have that angle here to give this difference here, or the relationship between the moment and the lever. And the interesting part now is that if I go and I do the design for that force, The moment arm on this case is this one over here, and in this case we have the force, so it's going to be over here, be probably a little bit smaller than that. Let's just erase this guy, and so it's probably like smaller here. And notice now that, so again, my lever resistance arm is this, and my lever resistance arm is this. And if I look at the angles, we notice that the angle is increasing. So in this case, it's a little bit higher. So it's getting like almost no moment because they are almost at 90 degrees relationship, which makes this guy going to 0. And that's why I don't have any force, and this position is kind of different than the previous one. I hope this answers your questions. Please let me know if you have anything else to add. And thank you so much for taking the time to go over these, you and Samson. Thank you.